Hi everyone, it's your friendly neighborhood science teacher, and today we're going to jump right back into the school year with another lightning lesson. This year we're going to be learning all about physics, which means we need to start off with some vocabulary words. The first word that we're going to be going over today is force. A force is a push or a pull. We see these all the time. Every time something moves, it's because it's being pulled by something or it's being pushed by something. Let's use an object as an example. I have a book. If I am holding this book up, I am pushing on it. I am preventing it from falling. If I slide it across the ground, I am pushing it. If I were to drag it by a rope, that would be pulling it. Any form of motion is a push or a pull, which gives us a force. Now that we know the basic definition of force, we can start by talking about two very specific forces that exist all the time. The first one that we're going to talk about is friction. You've probably noticed that if you are pushing something really heavy across the ground or pulling a really heavy object, you feel some resistance from that object. That resistance is caused by friction. Friction is a push in the opposite direction of motion that causes that feeling of something being heavy when you have to drag it. If I was pushing this book across a surface, it would have friction. If the book was moving this way, friction would be acting on it in the opposite direction. So when we are pushing that book, we have both forces happening. Now, friction is also affected by what surface you are pushing something on. If I am pushing a hockey puck across a freshly cleaned ice rink versus a gravel driveway, I'm going to get different amounts of friction. The smoother the surface is, the less friction you have. However, we will always have at least a small amount of friction because every surface has friction between it. But we can lessen the amount of friction by choosing a smooth surface. You have probably noticed in your own homes that if you are walking around in socks, you might slip if you go across your kitchen floor. That is because there is less friction and your sock decreases the friction between your foot and the floor even more. Our third and final word for this video is gravity. We feel the effects of gravity all the time here on Earth. But what you probably didn't know is that gravity exists on other planets too. Gravity is the pull towards the center of the largest mass close by. In our case, since we are on the planet Earth, the largest object near us is the planet itself. So when we are standing, the gravity we feel is towards the center of the Earth. Technically, all objects exert gravity on one another. It's just too small to feel in comparison. When we're drawing diagrams, however, we usually show gravity with an arrow pointing down. It really means towards the center of the Earth, but in pictures we show it as down. Let's take a look at my book again. You can see that my hands are holding it up to combat the effects of gravity. If I didn't hold it here, the book would fall down and be pulled towards the center of the Earth. When I'm holding it like this, we have balanced forces. I am pushing up on the book with the same amount of force that gravity is pulling it down, which balances it out and means that it is not moving at all. If I push harder than the force of gravity acting on it, or I were to drop it, we would get unbalanced forces and the book would start to move again. Forces always act in pairs, so for every stationary object, you should have at least two forces happening. The first one is gravity, because everything is being pulled towards the center of the Earth all the time. The second one is going to be the floor or whatever is under the object, pushing it back up. When we have forces that are balanced, we get objects that are stationary or not moving. If we have unbalanced forces, we get motion. So in that example with the book, if I am pushing it across the floor, I still have the pull of gravity pulling it down as well as the floor pushing it up, but now I have another set of forces in play. I have friction acting against my motion, but my motion is hard enough to overcome friction, which would be a force in the direction of motion. If you are ever stuck with trying to label forces on a diagram, just remember that you should always have gravity in your picture, and you should always have the force of the ground or whatever under the object pushing up on it. Then you can start to think about friction and motion. I hope this helped you start your learning on physics a little bit. In this video, we went over the definitions of force, friction, and gravity, so now you can use them in your next lesson. I'll see you in the next one, and I hope you have a great day. Bye!